Hello everyone, I am going to help you with the post-lab calculations for your experiment 603, which is resolving two-component data. Okay, so what are the two components that we are going to use? So please watch the virtual video so you will understand how the experiment is being conducted. But I will give you a summary here. What is this experiment is about? So you are going to resolve two components that you will be given as a mixture. So the mixture that you will be given is going to be consist of sand and salt. Okay, salt. Sand is silicon oxide, SiO2, sand and salt. So sand is SiO2, your silicon dioxide, and salt is sodium chloride. So you will be given a mixture with these two together. You know the sand is a grainy substance, sodium chloride is what we find in our table salt, that's also a white powder. So you're going to be given a mixture. We don't know how much we have in it, but it has a certain amount mixed together. Okay, so your identification code of the unknown going to be unknown number 1, and then you're going to take a beaker. First you're going to get the mass of the beaker, okay, before we put our sample. So that mass of the beaker, empty beaker, is going to be 112.314, and then you're going to be adding a certain amount of sand and salt together, and then you're going to get the mass again. That's going to be mass of the beaker plus the unknown sample, 115.600. That's going to be mass of the beaker with the unknown sample. Okay, and your goal is to separate these two components. They both are solids mixed together. Okay, how are we going to do it? You're going to be using the solubility. Now between sand and salt, sodium chloride, which one do you think is going to be soluble in water? Can we dissolve sand in water? No, right? But the sodium chloride, table salt, is going to be readily soluble in water. So what you're going to do is you're going to take about 50 milliliters of deionized water. You're going to pour it here, and then you take a rod, glass rod, and then you're going to mix it thoroughly, or you can use a spatula. You mix it thoroughly so the sodium chloride in your mixture will dissolve, whereas the silica or the sand will remain as a grainy substance. So after dissolve, you will still see a liquid, but now the sodium chloride is going to be in the liquid, whereas the little grains of sand you will see at the bottom. Okay, now the next step is going to be, you're going to remove the sodium chloride. So this is chloride, sodium chloride from this mixture. How are we going to do that? You're going to do a filtration, a gravity filtration. You will see in the virtual video how the filtration is being done. Please watch the video so you will understand what's the experiment and how everything is being conducted. Okay, so what you're going to do next, you're going to set this up to do a gravity filtration. You use a funnel, and then you use another beaker. Okay, that's going to be your beaker 2. And then before we do the filtration, you want to make sure you get the mass of the beaker. That's going to be the mass of the beaker 2, which you have here. Mass of the beaker 2 is going to be mass of the beaker 2. That's going to be this one right there. Mass of the beaker 2. This is the second beaker. That's 79.954. And then you take this mixture where you have sodium chloride and sand, and then you're going to filter. Before you filter, you put a filter paper here. Okay, filter paper, and then you're going to pour your solution over. When you pour the solution over, the silica or the sand will end up on the filter paper, whereas the sodium chloride gonna go to the bottom, filtrate. Now we separated the two. And the next step is we want to dry this. Now the sodium chloride is with water, because remember we had about 50 milliliters of water. So we want to get rid of water. How are we going to get rid of the water? We're going to keep this sodium chloride with water on a hot plate, and then you're going to heat it. Okay, you're going to heat it until water boils, and at the very end you will see some white precipitate, which is going to be the salt alone. And then you're going to let the beaker to cool down, and then you're going to get the mass of the beaker plus the sodium chloride. Okay, after you dry it. And then for the filter paper where you have the silica, you're going to put that on a watch glass. So the watch glass and the filter paper together, you're going to get the mass before you do the filtering. So mass of the watch glass and the filter paper, that's going to be 33.881. And then after you filter, you take this filter paper that is carrying your sand, and then you're going to put it over here. That is the filter paper with the sand. You will see in the virtual video, first you're going to dry it over boiling water, and then you can keep it in the oven to get the silica to dry. Okay, after you dry it, now you have dry silica, which is going to be your sand, and you also have the solid sodium chloride recovered in this beaker. Okay, so the mass of the watch glass, filter paper and silica are going to be, after it completely dry, 35.361. Now with this data, we're going to do our calculations and conclusions. Okay, so in a nutshell, that is what you're going to be doing in your experiment. When you watch the virtual video, you guys will understand how it is being performed, and also make sure to read the procedure in your textbook, so you'll understand more details about the experiment. Okay, now with that in mind, let's go ahead and see how to perform the calculations. Okay, now it's again it's not that hard calculations, it's pretty easy. You might be able to do it without my help, but it's always to have a backup help too, right? So we'll go ahead and help you to do the calculations. If possible, try to do it alone and then check my work to see if you got the right answers. Okay, so for example, the first one, calculate the mass of the unknown mixture that you analyzed. How do you find the mass of the unknown mixture? Remember, we started with the one beaker. Mass of the beaker 112.314. Mass of the beaker plus the unknown 115.6. So the mass of the unknown basically going to be the difference between the two, right? It's quite straightforward. 115.600 minus 112.314 grams. Make sure that you put the units as well. And it is a subtraction. We go by the rules for the decimal places. We go by the least number of decimal places. Both of these you have 3. So we want to keep our answer in 3 decimal places. So when you do subtract, make sure you do the calculations with your calculator. Sometimes I tend to do some mistakes, so you can catch if I have done any mistakes also when you also do your own calculations. Okay, and then if you find out anything wrong in my calculation, please feel free to let me know so I can correct it for the whole class. So when you do this subtraction, you will get a number like that. So that's the mass of the mixture that we analyzed. Easy, right? And then the second one, calculate the mass of the sodium chloride recovered. So the sodium chloride we put in the beaker 2. So the mass of the beaker 2 plus sodium chloride 81.704. So when you subtract that, the mass of the beaker 2, we can get the mass of the sodium chloride recovered. That's going to be 81.704 grams minus 79.954 grams, right? What would you get? So again, we go by the significant figure rules, which is the least number of decimal places. Both of these has 3. So we have to keep our answer in 3 decimal places, right? And that would be 1.750, 3 decimal places, grams. Okay, so that is the mass of the sodium chloride recovered. And then the next one going to be calculate the mass of silica, SiO2, silicon dioxide recovered. Again, we have silicon dioxide, or our sand is on the filter paper with the watch glass. So the difference between the last two data will give us the mass of the silica, right? 35.361 gram minus 33.881. Again, there are 3 decimal places. We have to keep it in 3 decimal places. That's going to be 1.480. Don't forget the 0, okay, because we need to have 3 decimal places. Again, please check to see if these calculations are correct, okay? Okay, and then the next page is going to be that you need to find out the percent sodium chloride and the silica that you recovered. So I posted another sheet for you to do your calculations. Let's go to that one over here. Okay, so the page 2 over here, I will start doing it from here. Calculate the percent sodium chloride in your unknown mixture. So the percent sodium chloride, how do we find out the percentage? You take the answer that you got in the previous page. We have sodium chloride recovered in question number 2. Calculate the mass of the sodium chloride recovered. That was 1.750. Okay, 1.750 gram is the sodium chloride that we had recovered, but we want to calculate the percentage. How do you calculate the percentage? You get the amount of sodium chloride you recovered and you divide it by the mass of the whole sample. Remember, in question number 1 is where we calculate the mass of the unknown mixture, which is 3.286. That is how you find a percentage. You take what you want, which is sodium chloride, and you divide it by the whole mass, which is 3.286, and you multiply by 100. That gives you the percentage. Calculate the percent. So you perform this calculation and write down the answer here. Okay, again you're going to keep your answer. This is a division 1, 2, 3, 4. You can keep your answer in 4 significant figures. And then similarly you can calculate the percent silica in your unknown sample. So the amount you the recovered silica is in question number 3, which is 1.480 grams, and you divide it by the mass of the whole sample, which is 3.286 grams times 100. That is how you would calculate the percentage. And you do that calculation and you write it down over here. Okay. And then the total mass of sodium chloride and SiO2 recovered. How do you find the total mass of sodium chloride and silicon dioxide recovered? So we had sodium chloride we recovered again in question number 2. You recovered 1.750 grams, and then the silica amount recovered 1.480 grams, and then you add these two together. Again, this is an addition. There are 3 decimal, keep your answer in 3 decimal, and then you add these two numbers together to find the mass of the sodium chloride and SiO2 recovered. Okay, and then the last question, calculate the percent recovery of the components. So percent recovery meaning the total amount that we recovered. We calculate the percent recovery, of the silica, we calculate the percent of the sodium chloride. Now that the percent recovery of the component. So your answer for question number 6, the number that you're going to get from here, question number 6, answer in 6. Answer you get for the question number 6, you're going to divide it by the mass that we used, which is 3.286 grams. Answer for the question number 6 in grams, you divide by 3.286, which is the total mass of the components that we used, times 100. This will give you the percent recovery of the components. Okay, so that's how you do the calculations. Again, you can keep your answer in 4 significant figures. Okay, that's all the calculations. Let me know if you have any questions. So bye for now.